Guys, it's great to have you guys back in class. Hope everybody's doing well from our little break away from school. Hope everybody's families are doing well and feeling okay. And you guys are starting to adjust to our new normal. Um, I know it's been a little while since we did any of this, so we're going to ease into it this week and then start ramping up beginning next week. So in Google Classroom, right below the video, you should see this Trig Identities worksheet. This is about proving the trig identity. So proving the left equals the right. Again, we want to make sure that we're only focusing on one side in this situation, not both sides. It's not our traditional type of equation. So I got 5 examples from this worksheet picked out that I'm going to go through. The video format will allow you to pause, to take notes if you want to, or to go back, and it'll also allow you to go at your own pace with the video as we go through the examples. So hopefully that will be beneficial for you. So let's start by taking a look at number 1. So I have the secant of x minus the tangent of x times the sine of x equals 1 over the secant of x. So for this one, I'm going to convert everything into terms of sine and cosine. So secant is equivalent to 1 over the cosine. Tangent is sine over cosine. And I'm just going to leave sine by itself. With this part over here, I'm going to combine because this is multiplication. I'll leave that alone. And sine times sine is sine squared. And cosine times 1 is cosine. So now I see these have a common denominator. So I can combine them. And we should recognize this numerator. 1 minus sine squared of x is one of our Pythagorean identities. That is equivalent to cosine squared of x. I now have the ability to cross out. I have cosine times cosine on the top. So I'm going to get rid of one of those and the one on the bottom, which leaves me with cosine of x. And your reciprocal identity for cosine of x is 1 over the secant of x. And that is what I am trying to prove. So again, I don't see any squareds in this problem, so I'm not looking at any of my Pythagorean identities. So my first step is to convert everything into terms of sine and cosine because I know I can work with those. All right, I'm going to move on to problem number 2. So I have 1 plus the cosine of x over the sine of x. I want that to equal the cosecant of x plus the cotangent of x. So I'm going to take a little bit of a unique approach to this problem and kind of work backwards a little bit. So I see on the right-hand side, I have 2 trig identities separated by a plus sign. But on the left, everything's combined. So I'm going to break up the left so I have 2 different parts. So I'm going to break this fraction up into 1 over the sine of x plus cosine of x over the sine of x. If I were to add these back together with the common denominator, I'd be right back where I started. So I haven't changed the value of the problem. And hopefully now you can see why we did that, because it makes it super simple. 1 over the sine of x is a reciprocal identity that is equivalent to cosecant of x. And cosine over sine is equivalent to the cotangent of x. So a pretty simple one if you can see how to get started. And that's going to be the key to a lot of these is what is my first step? What is going to get me on the path to proving the left is equal to the right? All right, so let's move on to our next problem, which will be number 5. So I have the cosine squared of y minus sine squared of y is equal to 1 minus 2 sine squared of y. My initial instinct when I see those squares is to check my Pythagorean identities. Looking at the left-hand side, there are no Pythagorean identities with cosine squared minus sine squared. But I see that everything on the right, the only trig function is sine, and I know I can change cosine into sine, so I'm going to try that. Cosine squared of y is equivalent to 1 minus the sine squared, and I still have minus sine squared of y. And now it's all coming together and looks pretty simple. I can combine my negative sine squared of y minus sine squared of y. I have 1 minus 2 sine squared of y. And I have proven that the left does in fact equal the right. Again, it's taking this first part and converting it into this. So again, it's one of those instances of how do I get started? So you got to analyze the problem, see that there's no cosine on the right, and do you have the ability to change that cosine squared into something with sine squared? And we do, and that's what led to the simplicity of the problem once we got started. So a couple more to go, and then I'll have you practice some on your own. So we're going to jump to number 6. Cosecant squared times tangent squared minus 1 equal to tangent squared. So I have a couple different options, but I'm going to convert everything to sine and cosine first. So cosecant is 1 over sine squared of theta. Tangent is sine squared over cosine squared. And I did this because I knew when I saw the tangent and the cosecant that the sine squareds are going to cancel out. So when I do that, I'm left with 1 over cosine squared of theta minus 1. 1 over cosine is the reciprocal of secant, so 1 over cosine squared is going to be the reciprocal of secant squared. And secant squared of theta minus 1 is one of my reciprocal identities, and that is equivalent to the tangent squared of theta. So this is a Pythagorean identity, secant squared minus 1. And again, you have access to that in your digital Google Classroom Trig Identities paper if you do not have that paper with you and handy. So tangent squared of theta equals secant squared minus 1. That's the one I used. To simplify problem number 6. My final problem, problem number 10, looks a little complex. So sine plus cosine equals tangent, or sorry, times tangent plus cotangent is equal to secant plus cosecant. So I have sine plus cosine on the first one. I'm going to leave that alone. I'm going to work with the second one and convert. Try and get everything in terms of sine and cosine. So I'm going to leave this one alone. And I'm going to put these two into terms of sine and cosine. So tangent sine over cosine. And cotangents cosine over sine. So in order to combine these, I need a common denominator. And that common denominator is going to be sine times cosine. So I'm going to multiply this one on the right by cosine over cosine. And this one on the left by sine over sine. So now I have sine times sine, which is sine squared, over sine cosine. And cosine times cosine, which is cosine squared, over sine cosine. Now I'm going to combine the second parenthesis into one fraction. That numerator should look super familiar to you, as sine squared plus cosine squared is equivalent to 1. So now I can multiply these two together. Now I cannot cross things out because I have addition in the numerator. So I'm going to go back to what I did earlier in problem 2 and break out this fraction into two separate fractions. Now I can cross out. I am left with 1 over the cosine of theta plus 1 over the sine of theta. And when those reciprocal identities are secant of theta plus cosecant of theta. And if you remember, all the way back in the beginning, we were trying to prove that this is equal to secant plus cosecant. which it is. So again, that was a little bit longer multi-step problem dealing with fractions and such. This is a great one to pause and go back and see the steps because it did involve changing the numerator, breaking up a fraction, multiplication. So hopefully this was a good refresher. And as you see on the sheet that we are working from, I have circled 5 problems for you. So I'd like you to do 3, 4, 9, 14, and 15 for practice. And I will post the solutions to those on, it's going up Monday. I'll post the solutions to those Tuesday. Again, use the Google Doc for questions if you have questions regarding this section, and I will do my best to answer those in a timely manner. Next lesson is going to involve a review of right triangle trigonometry. You'll also see the solutions to the work you did when we were last in the building face-to-face on the simplifying the trig expressions that had the dot to dot that should have created a beautiful little penguin for you. I'll post those solutions in this section. And if you have questions regarding those or want to go over any of those, we can do that as well. Again, hope you're doing well. Stay in touch. Hopefully you're not too overwhelmed. Use your time wisely and spread it out. And again, this week we're just focusing on remediation, going back over and refreshing what we're going to do. And next week we'll have the assessment up and ready for you to go beginning Monday the 30th, I believe.